Welcome, my fabulous chemistry students, on to homework number 5. We're going to do some more heat equations, but now I'm going to take in the heat of fusion and the heat of vaporization into account. So different kinds of problems. Basically, the same thing with a mix of new vocabulary and, again, some algebra. So specifically, heat of fusion first. Heat of fusion, that's where we melt, okay? It says, why can't we use MCAT to calculate these? Well, it's because now we're going to deal with change in potential energy because it's where it's melting. So now it's not going to be a change in temperature, okay? Does that make sense? So here's our equation, heat of fusion. Q is going to be equal to the mass times H sub F, and H sub F in our reference tables, table B is 334 joules per gram, okay? Here's an example. How many joules are required to melt 255 grams of ice at 0 degrees? So here's my keywords. I'm melting. Heat of fusion, melting. So now I can say Q. Don't know it. Mass says 255. I need to use H sub F, which is 334 joules per gram. Plug it in. Q is going to equal, and I should say X there because I'm telling you it's X, but I like to keep it Q, to be honest with you, just because it makes me know what I'm solving for. For me, it helps me, oh, sorry, that's supposed to be 334. It helps me realize at the end, are my units right? If I did everything right, my unit should be what that says. So 334 joules per gram. Here my grams are going to cancel out. I'm going to multiply these two together, and you guys are going to give me a new Q. Sorry, that's supposed to be a Q, not a G. You guys are going to be able to say Q equals in some sort of joules. Okay, easy peasy. Here you got some example problems. I'm going to help you with some of the keys, and you're going to do them. So it says, what is the total number of kilojoules needed to change ice to water? Ice to water melting. There's my fusion, so there's my HF equation. So Q says, what is the total number of kilojoules? Don't know. That's my X. My mass equals 15 grams. And my H sub F is I'm sorry, I got it mixed up, right? 334. I was going to say 433. Being a little dyslexic. It's getting late. All right, so I just have to plug this in. I'm going to have Q equals 15 times 334. Number 2, I have 1.0 times 10 to the 5 joules. This is why we get into kilojoules sometimes. To melt ice. Tells me right off the bat, heat of fusion. Gives me my Q. It says I'm at 1.0 times 10 to the 5 joules. That's, I can move this over, right? 1.0, I can go 1, 2, 3, 4, 5. Bow, bow, bow. It's 1 with 5 zeros. Mass, I don't know. But H sub F I do. 334 joules per gram. All right, so let's plug this in. I have 10,000 joules. It's going to equal my mass in X times 334 joules per gram. You need to divide both sides by 334. Maybe not take up as much space as I do. And you'll get a new number for your mass. Okay, you getting the hang of this? I'm going to let you do number 3. I'm not even going to set it up. Oh, wait, what does it say? It says in question 1, is heat being absorbed or released? Is this process endo or exothermic? Well, I guess I'm going to talk about it. So if I'm melting ice, is heat going into the system or leaving it? Heat is going into the system. So it's endothermic. I have to add heat to get it to melt. All right, so there's heat of vaporization equation. Again, I'm going to be dealing with potential energy changes, so the temperature is not changing. Here, though, I'm looking for vaporize or boiling. Okay, how many kilojoules of energy are required to vaporize? So I have Q, I don't know. I have mass is going to equal 423 grams. And then we have this H sub V. Now our new variable. If we look in table B, that is 2,260 joules per gram. It takes a lot more heat to get 1 milliliter of water to boil than it does to get 1 milliliter of ice to melt. Okay, so this is H sub V, 2260. And I'm just going to set these up for a plug and chug. Q equals 423 grams times 2260 joules per gram. And I'm going to get a new number. And then I have to divide that number by 1,000 to get from joules to kilojoules. So my initial number is going to be in joules, and then I'm going to have to say Q. I wrote a G. So I'm feeling dyslexic right about now. I must be getting tired. Then I'm going to have to take that Q I just got and divide it by 1,000 to get it into kilojoules. Okay? Don't get hung up on the joules thing. Let's make sure we know which equation to use. So here it says, what is the total number of kilojoules required to completely boil? That's H sub V. I don't know the Q. I know my mass is 100. I know my H sub V is 2,260. Plug it in. Q equals 100. So it looks like a 7. I swear I wrote 100. I swear I wrote 100. 100 times 2260. You guys can get me a Q. Okay, in joules. Okay, and then it wants me to do it in kilojoules. So then I have to divide Q by 1,000 to get my final answer in kilojoules. Okay. At 1 atmosphere of pressure, well, we don't use pressure, so don't worry about that. I have a mass, boiling point. Boiling point. At the boiling point, potential energy. I have joules, Q, 34400 joules. Mass, 25 grams. What is the heat of vaporization for this compound? Okay, so now I'm just going to solve for H sub V because it's for a different thing other than water. So plug it in. I have 34400 equals 25 grams times X. Divide both sides by 25 grams. And now I have a new H sub V for my new substance. Okay, so I'm looking for keywords to help me out. Here's a little throw you a bone for the next stuff. This device is called a bomb calorimeter. This is the amount of heat given off that I can measure, the heat given off, and we're going to find when I hold volume constant. That's what this cylinder is going to have to happen. So there's going to be a small incineration inside, if you will. It's going to give off an amount of heat, and I'm going to be able to measure it. It's cool. Boom! So listen, now that we're done with this, sorry the video took on so long, but it's this math stuff, and I'd like it if you can get it one time through. If not, of course, you come see me in class, and I can help you out with your algebra. Now you can finish whatever pages in 4 and 5 you couldn't do before. Remember, heat of fusion, I'm looking for melting. H sub V, I'm looking for vaporizing or boiling. Okay, and that's how I know when to use each equation. The equation's the same, but the numbers are different from H sub V to H sub F. So there's where the issue comes into play, okay? Then there's going to be a Castle Learning quiz when you're done with all your practice called Heat and Reactions. That's what you need to take on Castle Learning, and you will all be all done with this section of the unit. So I'll see you guys in class.